Here are your example problems for 7-7. 7-7 is about area and perimeter of similar figures. So let's talk about our key concept here first of all, because this basically is the entire lesson right here in this box if you really get down to it. When we're talking about perimeter in words, if we have a figure B which is similar to figure A by a scale factor, then the perimeter of B is equal to the perimeter of A times that scale factor. That's all there is to it. So if you're looking for the perimeter of figure B and you know the perimeter of figure A, it's a matter of multiplying that perimeter of A times the scale factor, and you can calculate the perimeter of figure B. When it comes to area, if the figure B is similar to figure A by a scale factor, then the area of B is equal to the area of A times the square of the scale factor. That's the only difference between the two. This is definitely something you need to either put in words or symbols or both on your gold sheet in order to keep track of it. But in this case, in order to calculate the area of figure B, we would have to take the area of figure A, which in some of these problems is just going to be given to you, and multiply it by that scale factor squared. So if the scale factor was 2, when it comes to the perimeter, we would just multiply the perimeter of B times 2. If the scale factor was 2 also, and now we want to look at area, we would take the area of figure B and multiply it by 2 squared, or 4. So if we were doing something with a scale factor of 3, up here we would multiply by 3 for perimeter. We'd multiply by 3. If we had a scale factor of 3 for area, we would multiply by 9, because 9 is 3 squared. So keep that in mind, and these problems will be very, very easy. Problem number 1. We have two rectangles that we're told are similar. One has a length of 6 inches and a perimeter of 24 inches. So I would draw that here and say that we've got 6 here and that the perimeter equals 24. Okay? The other has a length of 7 inches. So I would draw that one here. So we have 7 now, and we're looking for, because we don't know perimeter, what is the perimeter of the rectangle? So we would see right away that the scale factor is 7/6. The perimeter of the original is 24 inches. Now this is one way you could do this problem like this. We could say that x equals 24 times that scale factor. We could cross simplify here like they did, and we end up with an answer of 28. There is another way to do this problem, however. We could take a look at this and realize that we have a proportion here. We could look at it in this way. We could say that 6 over 7, 6 is to 7 as 24 is to x. And we would end up with 6x equals 7 times 24 equals 168. And then, of course, we have to divide both sides by 6. And we get x equals 28, just like they did in their problem. So you can do this either way. Since so many kids are really good at doing proportions, I'm going to show this way most often. But you can always calculate the scale factor and then use the scale factor to calculate the other one, just like we did a couple of lessons ago. Please press pause and do letter A. And here's problem number 2. In a scale drawing, the perimeter of the garden is 64 inches. So I'm going to put right in here P equals 64. The actual length of AB is 18 feet. So I'm going to label that here, that's 18 feet. What is the perimeter of the actual garden? So again, they're going to do the math here in order to take the 18 feet to 24 inches, and I'm going to introduce you to a really interesting concept here. What they did is they changed all the feet to inches because we have inches here and feet here, so notice what they did here, and they came up with a scale factor of 9 over 1. And then additionally down here, once you get your answer, you have 576, and then we want it in feet, so we change it to feet. This is the way I would do this problem. Again, I would rely on the fact that so many students are really good at solving proportions, and I would look at it this way. We have 18, and I would actually write feet here to keep track of this for this particular problem, so you see the relationship here is to 24 inches. Right here is where I got this from, these two sides. And then we also have, we don't know how many feet the actual garden is, but we do have the map, which is 64 inches. Now you're probably thinking I need to start changing some units here, and I want to show you something that in fact you actually don't when you're dealing with a proportion like this. So we can have 24 times x, of course, is 24x, equals 18 times 64, which is 1,152. We, of course, have to divide both sides by 24. And when we do that, we realize that x equals 48, and it works just fine. When it comes to the case of a proportion like this, it is okay to go feet to inches, as long as you go feet to inches over on the opposite one, and things will work out. And when you get done, your answer will be, in this case, 48 feet, just like here. I think this is a little bit more straightforward way to do the problem. You certainly may do it exactly like they show in the book. Please press pause and do letter B. Now let's take a look at how we did problem number 3. The Eddingtons have a 5 by 8 foot deck. You can see it here, fairly small, on the front of their house. I'm sorry, I should say porch, on the front of their house. They're building a similar porch on the back with double those dimensions. Find the area of the back porch. Our scale factor, as we can recognize right away, is 2, because they're doing it with double the dimensions. So you can do this problem one of two ways. We could calculate this area of the front porch, which is a 5 by 8, so that's 40, and then multiply the 40 by the scale factor squared, which is 40 times 4, which is 160. Another way to look at this problem, in a way that a lot of people see this in a more clear manner, is if we were to double the size of that deck, instead of being an 8 by 5 deck, it would be a 16 by 10 deck, which makes really easy math, because the area then would be 16 times 10, which of course is 160, and we would have square feet for our unit, just like in this one. Do these problems one of two ways. You can purely use the first area times the scale factor squared to calculate the new area, or you could just change the dimensions of the original figure by the scale factor and then figure out the area of that. Perfectly good ways to do the problem in either case. Please press pause and do letter C. It would be a good idea for practice to do this problem both ways. Calculate it both ways and really get good at doing this.